Okay, today we're going to start with a code exercise that uses the forces of physics. We're going to look at these objectives today. Students will be able to compare weights, distances, and forces of an object. So in this exercise, we are basically going to follow this printout from Learning Resources. We're going to have Botley start at a start line and go to a ball which is 23 inches away from the start line, and he's going to push that ball past a cone which is 27 inches from past that start line. So we're going to run 3 trials with 3 different balls. So you can use the provided ball. I chose a golf ball and a rubberized ball as the 3 balls. So this exercise has 4 pages. It has directions for the teacher and how she or he progresses through the lesson. So basically we set it up, each object. So the first object is going to be orange ball that comes with Botley. And the golf ball. And finally that yellow rubberized ball. And we're going to do 3 pushes with each of those balls, which are the objects, and we'll see, and the answer is, did the object go past the cone? Yes or no. So yes or no goes in these boxes here, and we fill that out. And then after we have that step done, we can have the kids learn how to do tallies by marking the tallies, and then finally take those tallies over to our last sheet and create a bar graph with the yeses and nos. Okay, to just see how many objects went past the cones. Okay. One of the things I wanted to point out about these different balls we have is the ball that comes with Botley is very light. It has many flat sides to it, kind of like a dodecagon. And we have a golf ball which has a different texture to it, but is heavier, has the dimples in it. And then this smooth surfaced rubberized ball, which has a similar weight to that golf ball, but might be a little bit heavier. So you use those terms to help your kiddos out, help them understand how weight goes into the process of force. The same exact force is given from Botley. We'll be using the face or the detachable robotic arms. And I put this stick in here so that he doesn't miss when it comes down the line. So the same force is given by Botley, but these balls have different surfaces and different weights. All right, so let's take a look at all our setup here. So I went over the sheets. You can read through those. And then let's look at the materials beyond the sheets. So you'll need your program cards. You need to have the students ask themselves, how many steps does it take to get down past the cones? So let's move the sheets out of the way so we can get to that portion, how we have this actually set up. So I'm going to go ahead and put that to the side. All right. So how we have this set up is we have some masking tape, just regular masking tape, and we set up at the 0, and we go down the ruler, down the yardstick to 23. See, 23 is marked, and then 27 is also marked. As you can see, I used a longer piece of masking tape because the objects sometimes go left or right instead of straight, and if they do go straight, they might hit. I've set up this little bumper from a eraser taped to the table. All right, so you can remove your ruler now that everything's set up. You can put your Botley on that start line. You can put start on here. There's your start line. And you can put your Botley on that start line. You can see there. And you can put your first object on that marker for the ball. you need to have the kids figure out how many steps it takes for Botley to get 27 inches. So they can test it, they can debug it, but it is 3 steps. So once you have your program cards out of the way, you can start doing your trials. Now once again, you're going to do 3 trials of each object. The first one is going to be of the ball that comes with Botley. Alright, so remember, clear by pushing delete. Make sure you delete on your robot. Let's make sure he's on. He went to sleep. Okay, he's on. Alright, he's ready to go. We'll go ahead and delete. Okay, he's deleted. And we'll use that 3 times. 1, 2, 3. He's going to travel down and hit that orange ball. Did the orange ball go past the line? So that's what you're going to use these sheets for. So put this sheet right here and we'll say, no, it didn't. Oh. All right, so that's the first trial, the first push. We'll take him back to the start line. Put the orange ball back on his marker. And we'll transmit that same program. Nope, and that didn't go the second time either. Okay, let's see what he does the third time. All right, looks like we're set. Goes down for the third push. Nope, he did not go that time either. All right, so we're going to change our object, put Botley back where he belongs, move over to the golf ball. Okay, so we have a golf ball in place. I'm going to transmit. Yes, the golf ball did go past. Okay, and we'll do 2 more pushes with the golf ball. Transmit. And you can have the kids make observations about how far the ball rolls after the cones, because that will be good scientific observations. All right, let's do the last one for the golf ball. All right, let's transmit. Okay. So we went past the cones all 3 times. All right, we're going to change our balls and put Botley back. Switch out the golf ball for the yellow rubberized ball. Okay, here we go. Let's transmit for the first push. Saw how that one was going. Didn't go straight, but it did pass the cones. Okay. Set Botley back where he belongs, and we'll do the second push for the yellow ball. Okay, so the yellow ball went 2 times. We do one more trial. set it back on the line. Okay. Set Botley back where he belongs. Okay, last push Botley. Okay. Good. Stopped at the bumper. So put yes down for that one. So what we could do now is make a telegraph. Telegraph is basically lines up and down until you have a 4, and then you do the cross out for the 5th. So if you can teach your kids how to do tallies, this would be a great opportunity. So we have how many no's? 1, 2, 3. 3 no's. 1, 2, 3. 3 no's. How many yeses do we have? 1, 2, 3, 4, 5, 6. We have 6. 1, 2, 3, 4, and then we cross through for the 5 and 6. So that's a tallygraph. So they learn how to do tallygraph there. All right, so that goes on to the next graph. We're going to use that information from the tallygraph to make our bar graph. So we can use this information. So how many yeses are there once again? 6. We have 6. So we can put in here, we have 6 yeses. 1, 2, 3, 4, 5, 6. And then how many no's we had? 3. 1, 2, 3. Now you can obviously fill that in. So after 9 pushes, we did 9 pushes, we had 6 past the cones and had 3 that did not. So you can fill those bars in however you'd like, but there you have it. This is a physics lesson and introduction to tallygraphs and bar graphs. Thank you.